This week on Engineering Newswire, we're finding out what went wrong on Mars, finishing up tests on enormous jet engines, and 3D printing super strong magnets.
We've been following GE Aviation's testing of the GE9X jet engine since this summer. The huge engine is destined for Boeing's 777X passenger jet and can produce 100,000 pounds of thrust. Now, testing is almost complete. Program leader Chuck Jackson said that the project went surprisingly well for a task with so many moving parts. We want to make a few tweaks here and there, but that is why we ran the engine early, to give us time to further enhance the product, he said in an article from GE Reports. The engine has undergone 167 hours of testing and has been observed by 1,200 sensors. Its fan blades are made of carbon fiber, which, along with the fan case, increases its efficacy by channeling air at a 27:1 pressure ratio. Parts made of ceramic matrix composites also give it unprecedented heat resistance at a relatively light weight. Although testing the engine is a big job, it didn't take as long as typical testing. GE worked for under 15 months to get the initial assessments done, while most similar jobs take 6 months longer. The engine parts were first tested individually under flight conditions, then brought together for the first complete engine test. Next, the first engine will be subjected to sub-zero ice tests to see how it will perform when flying in cold temperatures. A second engine will also be built by April 2017, using the information learned from testing the first one. After both have been tested, the design can go on to the engine certification process and flight testing.
The Schiaparelli lander is lost, dashed against Mars' surface in a landing that ended the probe's short mission. The exact cause of the crash is still under investigation, with the European Space Agency working hard to continue to operate their remaining spacecraft. Safe in orbit is the Exomars trace gas orbiter, which will try to sniff out methane, a possible indicator of life in the atmosphere. The ESA recently released a video that gives a neat overview of human exploration on the red planet, including their recent Exomars project. Last week, NASA and the ESA investigated the crash and determined that it may have been caused by a parachute activating too quickly and landing thrusters shutting off too soon. Schiaparelli broke into 3 pieces, with the parachute, the back shell, and the main body of the lander hitting the ground at more than 180 miles per hour. Since then, NASA and the ESA have been using the Mars Reconnaissance Orbiter and Trace Gas Orbiter to observe what's left of the Schiaparelli lander, careful not to draw conclusions too quickly. One thing's for sure though, it probably wasn't aliens. The methane that has already been found on Mars is likely a byproduct of geological activity. India's Mars orbiter is currently also looking for methane, but hasn't found anything yet. Europe's next Mars shot is a 2020 lander, which will also be supported by the Trace Gas Orbiter. With several missions in the works, Mars is already getting crowded.
Here's a development that might stick around. Researchers at Oak Ridge National Laboratory have 3D printed permanent magnets. The manufacturing process results in stronger bonded magnets and less waste than traditional methods. These magnets can be used in the automotive and energy industries, including motors, generators, and large windmills. In order to make them, the researchers used one of 2 techniques: binder jetting, in which material is laid down like ink from an inkjet printer, or big area additive manufacturing. Along with having an exciting acronym, Big Area Additive Manufacturing also allows bonded magnets to be printed using no tooling at all and generating no waste. Leftover material can be used to print the next project. Neodymium iron boron pellets and polyamide pellets are combined in order to create magnets that can then be extruded into complex shapes and a variety of sizes. Parents Paranthaman of the Critical Materials Institute at Oak Ridge Labs says that the program is part of an effort to bring knowledge from industry leaders, universities, and government labs together to develop new materials and manufacturing techniques.
Do you have story ideas?
Comment below and we'll cover them in an upcoming episode.
This has been your Engineering Newswire.